In some cases, it's easy to kind of eyeball a circuit and say, yeah, this signal can be written as a mathematical function of another signal, but sometimes this is not so easy to do. So our idea is basically to prove as many signals as possible to be deterministic by doing this lighter weight reasoning, and we only want to resort to constraint solving only for the non-obvious cases where we run out of other possible solutions. So this brings me to our technique, which is basically at a high level, you have this interactive loop between two components, namely the SMT solver approach and the static analysis approach. And these continuously exchange information with each other through a shared knowledge base. And what does this shared knowledge base contain? Well, it contains two types of things. So first, as Daejun was saying, range information turns out to be useful, so it will compute range information for all the signals. But most importantly, it basically has information about which signals have been proven to be deterministic. And if at any point in this loop, we find that the output variables are a subset of the deterministic variables in our knowledge base, that means the circuit is properly constrained. Otherwise, we're going to first resort to our static analysis because it's cheap, and we're going to try to infer as much range information as possible and try to prove as many variables to be deterministic as possible. And at some point, we will no longer be able to make progress using static analysis, and when that happens, we will hand things over to the SMT solver. And the SMT solver will kind of continue the work started by the static analyzer and try to prove more signals to be deterministic. But the good thing about this SMT solver is it can also potentially prove that an output signal is non-deterministic. And if that's the case, then if that happens, we can conclude that the circuit is buggy. But otherwise, we keep repeating this until we can no longer make progress. And if we didn't determine verified or buggy, we can also return unknown. And as you will see later, the unknown case will happen because of solver timeouts, right? Because when we make a query to the SMT solver, it may not be able to provide an answer in some cases. And the key point that I want to make here is that the SMT solver and the static analyzer play a complementary role each other in the sense that partial results from one phase can be useful to the other, as we will see shortly.